Hey guys, here's a problem from today's Codeforces round. A beautiful set of numbers is defined as a set of numbers such that for each pair of numbers, x and y in the set, either x must divide y or y must divide x, or both. A number x divides a number y if there's an integer k such that x times k equals y. To construct the set, you are given two numbers as an input, L and R, and you can construct the set from the integers between L and R, inclusive. The problem asks you to find, number one, the maximum size of the set that you can construct, and number two, how many different ways you can construct the maximal set, or how many different sets there are that have the maximal size. First of all, to solve this question, we need to remind ourselves what the condition of the set actually was. The condition was, for any two elements, x and y, either x divides y or y divides x. That means that if for any two numbers one of them divides the other, that means one of them is a multiple of the other. So for any two numbers in the set, a and b, b equals k times a. So now, to make it nice, let's sort the elements in the set. We can now clearly see that an element must be a multiple of the one to the left of it, because we can just choose two adjacent numbers. Since the smallest multiple of number, other than the number itself, is 2 times the number, we can construct a maximal set like this. We fix an element x as the starting number, we make the next 2 times x, and the next 2 squared times x, and so on, as this will keep the differences between these consecutive elements as small as possible, hence allowing us to put as many elements in the set as possible. This means that we can find the largest power of 2 that is less than r over L, then the number of elements in the maximal set is the power plus 1, as the kth element in our maximal set construction was 2 to the power of k minus 1 times x. So this means that if the maximal size was k, and if we choose an element x to be the start of the set, then the end number will be 2 to the power of k minus 1 times x. Therefore, we can divide r by 2 to the power of k minus 1, and all the numbers between L and that will be able to create a maximal set, so we add the number of numbers to the answer. Next, realize that this isn't the only way to do this. A multiple doesn't just have to be 2 times the previous number, it could be 3 or 4 times, for example. But realize that we have to either have all of the jumps between the adjacent elements being all 2's, the one we just did, or 1 times 3 and the rest times 2's. This is because, say there are, for example, 2 times 3's. That means that that is a times 9, but we know that 8 is equal to 2 to the power of 3. So we could have had 3 times 2's, but we had 2 times 3's, which is not the maximal set. Otherwise, if we multiply it by a number bigger than 3, that means that we can always split it into 2 or more times 2's, because it'll be greater than or equal to 4, which is 2 squared. So, if the other option other than the maximal set construction we had is 1 times 3 and the rest times 2's, realize that if the maximal size was k, there are k minus 1 adjacent pairs. That means that there are k minus 1 different places we can place the times 3, and for the rest was times 2's. So each starting value of this option will have k minus 1 different ways of constructing it. Now, we can check which starting values it can take by dividing r by 2 to the power of k minus 2 times 3, because that is the previous one, divided by 2 times 3, and multiplying the number of elements between L and this number by k minus 1 and adding to the answer. And if we combine this answer with the previous answer, we get our final answer, which we can output and solve the question. I hope you enjoyed the solution, and stay tuned for more interesting and cool problems.